Hello friends, welcome to Education Buddy. In this video, we'll try to understand the chapter lens and we will try to understand the basic concepts. So let's begin with some basic and fundamental definitions. First one is linear magnification. Linear magnification is image length by object length and it is denoted by m. Next one is center of curvature. What is center of curvature? Just imagine that this is a lens L1 and the center of sphere of part of which a lens is formed means a lens is made by a part of a circle and this is another circle. These two circles part made making the lens L1. So the centers of these two circles are the center of curvature. So these L1 are lens and C1 and C2 are center of curvatures. Next one is radius of curvature. This is a lens and this lens is formed by these two lens part, these two circles part. So the radius of sphere of part of which a lens is formed means this is a sphere and its center is C2 and this is a sphere and its center is C1 and C1D. D means this point is D and this point is B. So C1D, this distance C1D and C2D, this distance C2 and D, this distance is called radius of curvature. Means the radius of the circle by which the lens is formed. Next one is principal axis or optical axis. What is principal axis? Straight line joining center of curvature of two faces with optical center of lens. Means the lens has an optical center. We will discuss later on this and the optical center and center of curvature joining lines means there is a optical center and this is the center of curvature. So these two lines are joined by this line. So this is called principal axis or optical axis. Now what is the optical center? And here it is C1 and C2 is the principal axis. C1 and C2, this line is called the principal axis. Now what is optical center? Let's discuss. Optical center is the point which lies on the principal axis through the rays of light passes without any deflection. So optical center is a point. The point which lies on the principal axis. This is a principal axis C1 C2 principal axis and through the rays of light passes without any deflection. This is a light ray and this is passing through this lens and without any deflection. There is no deflection. So that's why this point is called O and O is denoted by optical center. Optical center is denoted by O. Next one is what is principal focus? Principal focus is nothing but a point onto which collimated light parallel to the axis is focused. Means this collimated lines parallel to the axis. This axis parallel collimated lights came and reflected through the lens, through the convex lens, and are pointing to or focused to a single point. If there are so many parallel lines and parallel lights and these are focusing, these are transferred from this convex lens and these all parallel rays, collimated parallel rays will point in a single point. So this point is called principal focus. So this F is principal focus and the distance between optical center and principal focus OF. In this case OF is the focus length. Next is There are some conditions, and this is very important for competitive exams. So let's understand. Just imagine this is an object and it is placed between f1 and lens's optical center O. It is placed between f1 and optical center, and there is a light. Just imagine that there is a light, and the right lens, this light is just here. Here is light, and here is the object, and there is a here is a just a cloth. There is a four means there is a rectangular cloth here, and we can see the image forming here. Okay, so what we will see, if the object is placed between f1 and O, is it looks like it will be virtual and erected, and it will be looks like enlarged, and here will be the enlarged image we will get. Here we will get a enlarged image, and on the same side, on the same side, and it will be look like it is coming from this here. It will be looks like it is coming from here, and it is virtual and erected. It will be virtual and erected image of this object. So if the object is placed between f1 and O, the object will be looks like virtual and erect, enlarged, and on the same side of the object. Next concept is object at f1. If the object is placed on at f1 and there is a rectangular cloth, the image will be looks like real and inverted. Image will be inverted and real, and at infinity, and the image will be made in infinity distance, and it will be highly enlarged, very big image we will get. So these things we have to remember. Next one is object between f1 and 2f1. If the object is placed between f1 and 2f1, the image will be looks like enlarged, and beyond 2f2 it will be made beyond 2f2, and it will be real and inverted. If we place a cloth here, and there is a light, and if we place a cloth, rectangular cloth here, we will see if the rectangular cloth is placed beyond 2f2, then the image will be formed, and the image will be enlarged and real and inverted. Next is object at 2f1. If the object is placed at 2f1, the image will be made beyond 2f2, and it will be same size with the object, and it will be real and inverted. Next is object beyond 2f2. If the object is placed beyond 2f2, beyond any position of 2f2, sorry, 2f2, yes, 2f1, beyond 2f1, then beyond 2f1, sorry, it will be 2f1. Okay, 2f1, and the image will be look like it is making here, and it will be between f2 and 2f2, and it will be diminished comparing with the image, comparing with the object, and it will be real and inverted, and it will be, remember, it will be formed between f2 and 2f2 if it is placed beyond 2f1. Okay, next is, here are some very most asked competitive exams question. So the red light has a maximum speed, maximum wavelength, minimum frequency, minimum deviation, and lowest energy visible light. That is why red light is used in traffic lights, because you can see from very long distance. This red light we can see from very large distance. Next is violet. Violet light has a minimum speed, minimum wavelength, maximum frequency, maximum deviation, highest energy visible light. So violet light is opposite to red. Is very important. Next is VIBGYOR. VIBGYOR. What is VIBGYOR? VIBGYOR is the lights. This refers to the colors of light. And if white color light is, if a light is light color is white, and if we divide white color into 7 different colors, it will be made VIBGYOR in sequence. Okay, the first will be V for violet, second is I for indigo, third is B for blue, fourth is G for green, fifth is Y for yellow, sixth is O for orange, and seventh is R for red. So these are 7 colors. Okay. Sir Isaac Newton discovered scattering and spectrum of light in 1666. This is called spectrum of light. Okay. Next is, so these are complete. So these are the main and fundamental things of light chapter, and you have to practice much more and just remember this all things, so you can go for any question. Okay, thank you very much. I wish this video is helpful for you. Thank you very much for listening.